Good morning, students. Today we will study about electrostatic or electric potential. Electrostatic potential of a body represents the degree of electrification of the body, and basically it determines the flow of electric charge. And we know that the charge always flow from higher potential region to lower potential region. And the electric field created by charge is conservative in nature, which does not depend upon the path to move charge from one point to another. It depends only on initial to final position of the points. Now the line integral between 2 points of electric field is same for all the paths between the 2 points. Line integral from A to B E dot dl is equals to same for all the paths between A and B. And if the path is closed, for closed path, it is always equal to 0. Line integral over the closed path E dot dl is equals to 0. Now, electrostatic potential difference. What is electrostatic potential difference? Now, consider a point charge positive plus Q is placed at O, and A and B are 2 points having position vectors RA and RB respectively, and let Q naught is test charge is placed at point P having position vector R. The electrostatic potential difference between points A and B is defined as the work done to bring a unit positive charge from point A to B in electric field against the electrostatic force. This is the definition of electrostatic potential difference. That it is defined as the work done to bring a unit positive charge from point A to B in electric field against the electrostatic force. Now, this is the diagram in which at point O a positive charge plus Q is placed, and there are 2 points A and B, and a test charge Q naught is at point P, and we have to move the charge from A to B. We have to move the charge Q naught from A to B. The position vector of A is RA, and position vector of B is RB, and position vector of Q naught at point P is R. Now, if VA and VB are the potentials at point A and B respectively, and WAB is the work done to move charge from point A to B, then VB minus VA is equals to WAB divided by Q naught according to the definition. VB minus VA is equals to WAB divided by Q naught. This is the potential difference. Now, the force on the test charge Q naught placed at point P due to source charge plus Q is given by F is equals to Q naught into E. Force on charge Q naught, test charge Q naught due to the charge plus Q which is placed at O is equal to or is given by F is equals to Q naught into E. To keep the charge Q naught in equilibrium, we have to apply an external force F is equals to minus Q naught E on test charge. This is a required force to keep the charge Q naught in equilibrium. Now let us suppose on applying this force, Q naught charge travels an infinitesimally small distance or small displacement, PQ is equals to dl. Then in this condition, the small work done dw is equals to f dot dl, and put the value of f, then we get dw is equals to minus q naught e in minus q naught e dot dl. dw is equals to minus q naught e dot dl. Now the total work done in moving charge from A to B, WAB will be equal to A to B dw, integral from A to B dw is equals to minus q naught line integral from A to B E dot dl, and divide both the sides by q naught, we get WAB divided by q naught is equals to minus line integral A to B E dot dl, and according to the definition or from equation first, WAB divided by q naught is equals to VB minus VA. So we get VB minus VA is equals to minus line integral from A to B E dot dl. Now electrostatic potential difference is defined as the negative of the line integral of the electric field between two observation points. This is the definition of electrostatic potential difference, according to which the electrostatic potential difference is defined as the negative of the line integral of the electric field between two observation points. If we bring a unit positive test charge from infinity to point B, then potential difference will be equal to VB minus V infinity is equals to minus line integral from infinity to B E dot dl, and V infinity is equals to 0, so we get VB is equals to minus line integral from infinity to B E dot dl. Now electrostatic potential is defined as the negative of the line integral of the electric field between infinity and observation point. Now electrostatic potential is also defined as the work done to bring a unit positive charge from infinity to the observation point in electric field against the electrostatic force, and this is represented by the above equation, which is VB is equals to minus line integral from infinity to B E dot dl. Now SI unit of electric potential and potential difference is joule per coulomb or volt. SI unit of electrostatic potential and potential difference is joule per coulomb or volt.